Okay, let's try another problem where we're going to need our potential chart. First, we're going to determine the half-cell reactions. And half-cell reactions are where you follow one element and what's happening with it. So I see that aluminum is going to aluminum with a +3 charge. And I know there are electrons involved, and I may see that, well, this has a 2 and this has a 2. By the way, you wouldn't have to have this balance with the other one. You could have the reduced version. So this must be a 6 electrons. In order to make this side is neutral, and so this side is neutral, there must be 6 electrons there. Okay, the other reaction is, of course, iodine. And I see that my more positive side is going to be this side, which makes sense because it's going to negative, so I'll leave some room there. And so for the electrons, they go on the more positive side, which is the neutral side on this case, in this case, so it's going to be 6. Okay, I've got my 2 reactions, and I might want to decide which one is anode and which one is cathode. And what I can see is that, let's just look at this one, I go from an oxidation number of 0 to an oxidation number of negative, so that's reduction. So the iodine is being reduced, and reduction occurs at the cathode. Aluminum is being oxidized, it's losing electrons, and that occurs at the anode. Okay, I don't have a lot of room here, but let's see what I can do. Let's find these reactions over here. And the first one I see is the iodine down here. And it is, let's put it right here, it is in the correct direction. You see I have I2 going to the ion, so I'm going to use this number as is, which makes sense because this table is a reduction table, and we said that this was reduction. Okay, let's look for the aluminum. The aluminum is up here. And the problem is the reaction that we want for aluminum is oxidation, and this is reduction. So that's not that big a problem. We know what to do. We're going to change that sign. Okay, and so now we have our 2 potentials. Okay, so it's positive, so that means this reaction is spontaneous. It can be used to do work, like a battery. It is a voltaic cell, not electrolytic. And one last thing I want to point out that you may have noticed and wondered about is that these half reactions had this coefficient with the here, and then when I looked here it didn't have those coefficients, so you might be worried that we need to multiply through by 3 or something. You don't. So it doesn't matter if what multiple of these you use. Like for the aluminum also, we just had one aluminum on either side. You just use that number there. Of course we had to flip the sign on that one.